Hello everyone. So through this video we are again looking at gravitational fields, A levels and IBDP. We are studying about Newton's law of gravitation and gravitational field strength. We will be doing questions right now. Read the first question. Radius of the earth is 6.4 into 10 raised to 6 meters. So visualize there is the radius of the earth given and the gravitational field strength at the surface of the earth is given to us, right? We have to find that assuming the field is radial, calculate the mass. So what we are given over here, we are given the radius, we are given the gravitational field strength, and we have to find the mass. So we need a formula which relates mass, gravitational field strength, and the radius. Now we had talked about in the previous video that in the gravitational field strength there is no radius, there is distance from the center which is involved. So how to tackle the question? First step to tackle the question would be to draw an appropriate diagram, right? So what is the first thing I have to do? I have to draw the diagram. So the earth is there. The radius of the earth is given, means the distance of the surface from the center is given to us, right? R is given to us, and we know the value of G. G is 9.8 newtons per kg at the surface, right? So what is the formula which relates G, mass of the earth, and the value of gravitational constant? So the formula we have to use here is G m upon r square, where m is the mass of the earth, because earth is the object which is creating the field, and we are finding the distance from the center of the earth. Now where is the field to be calculated? It's at the surface, so the radius is important. Here there is an assumption that all the mass of the object is concentrated at the center, so we take that assumption. So we assume that all the mass is here, and we know the radius of the earth, that is the distance of the point from the center of the earth, which is also the point having the mass as per our assumption. So that gives us 9.8 newtons per kgs is equal to the value of G, which is 6.67 into 10 raised to minus 11 into mass M. M is how much? This much upon radius square, right? Radius of the earth is given to us. It's in meters, which is the standard units, 6 whole square. Now when I go on solving this further, I take this down and this up, everything apart from m on the other side. So I get 9.8 into 6.4 square into 10 raised to 12 upon 6.67 into 10 raised to minus 11 is equal to the mass of the earth, right? And because we have taken all the standard units, the mass will come out to be in kgs, right? Now when I solve all of this, I get my answer as 6 into 10 raised to 24 kgs, right? You can say 6.0 because there are two significant figures here, so you can say this is 6.0, right? That is the mass of the earth. Now in the second question, what is there? Quickly you can pause and read the second one. Now the radius of the moon's orbit around the earth is given. It's important that we are able to visualize what's happening here. Radius of the moon's orbit around the earth. So basically the earth is there and the moon is orbiting. Radius of the orbit is given, right? Which also means distances between the center of the earth and the moon. Now what are the radiuses? Radiuses are 3.8 into, what is the radius? That means radius of the orbit 3.8 into 10 raised to 8 meters. We have to find the strength of Earth's gravitational field. So Earth is the one creating the gravitational field at this point, at this distance. So in the orbit, we have to find what is the field Earth is creating. So we need to find the value of G. We have the value of R, which is the distance between the point and the center of the Earth, right? So this is given to us. R is, see here, the R is not radius of the Earth. It is the distance of the orbit from the Earth, which is 3.8 into 10 raised to 8 meters, right? What else do we have? We have the Earth's mass calculated in the previous part, 6.0 into 10 raised to 24 kgs. Now when G is to be found out, straight away we know there is the one formula which is connecting all these numbers, right? Same formula we had used in the previous one, but what was the difference? There the gravitational field strength was at the surface of the Earth. Here it is at the orbit of the moon, right? Which becomes 6.67 into 10 raised to minus 11, which is the standard unit, into mass of the Earth, which is in kgs, upon r square. Now my r is 3.8 into 10 raised to 8 whole square. When I make the calculations, I'll get the answer in standard units, which is Newton per kgs, right? And when I do this, I get 2.8 into 10 raised to minus 3 newtons per kg. Okay. Now the third, so this is the same thing. We are finding the gravitational field strength and we are using the formula directly. Now the third one is mass of the moon is also given. Calculate the gravitational attraction between the Earth and the moon. So basically we have to find the force, right? Distance between the Earth and the moon is given. Masses of both of them are given. Force is required. So we straight away use the formula. F is equal to G M M. Small m represents mass of the moon upon r square. Distance between them, the square of that. So 6.67 into 10 raised to minus 11 into the mass of the Earth. 6 into 10 raised to 24 kgs into the mass of the moon. Sorry, this is 22 upon r square. What is r? 3.8 into 10 raised to 8 square of that. And force will be in newtons here. Why? Because we have taken everywhere the standard units, so force will also be in the standard unit. So when we calculate this, we will get 2.1 into 10 raised to 20 newtons. Now just think about it. We are on the earth, still our weight or the pull of the earth on us is how much? 600 newtons. If your weight is 60, if your mass is 60 kgs, your pull will be 600 newtons. But moon, which is so far away, 3.8 into 10 raised to 8 meters, it is having a pull of 2.1 into 10 raised to 20 newtons, right? So this difference is there. Such a big pull of the earth on the moon. Why? Because the masses are huge for both. That's why there is a strong gravitation force, even though the distance is large. So in this question, what we have done, we have learned how to use the formula of gravitational field strength. Yes, we have learned how to use the formula of force of attraction, right? And on basic example here, we have a practice question here. So I would want you to pause the video here, attempt the question and answer this question in the comments below, right? I hope this was helpful. If you like this video, please follow us on Facebook and Instagram and subscribe to this channel. Please feel free to share with your friends, right? You can answer the question in your comments. Thank you so much.